Bismillahirrahmanirrahim. Assalamualaikum dan selamat sejahtera. In this video presentation, we, the members of Group 8, will be presenting our video on program execution. This video is conducted for the subject Introduction to Computer Organization, subject code CSCI 1302 under our lecturer named Madam Asia binti Ismail. First and foremost, let me introduce you to the group members. Firstly, on the left side of the screen, we have Brother Haikal Akif bin Syari as our group leader. Second, we have me, Brother Arman Nuri as our researcher. Our third member is Brother Muhammad Aiman Akim bin Adnan as our simulation expert. As for our fourth member, we have Sister Qasdina Azlin binti Azhar as our resource collector. And lastly, we have Brother Muhamad Arash bin Abdullah as our summarizer. Now, what exactly is program execution? By definition, program execution is the process by which a computer or virtual machine reads and acts on the instructions of a computer program. Each instruction of a program is a description of a particular action which must be carried out in order for a specific problem to be solved. In the most broadest and general sense, program execution is the process of executing a written program or code in its entirety. Some examples of the operating system's activities are: the operating system loads program into the memory. It also executes the program, it handles the program's execution, it provides a mechanism for process synchronization, and it also provides a mechanism for process communication.
Assalamualaikum. My name is Haikal Akif. Today I will present about the flow on how computer read the codes. So how does program executes? Firstly, a program is compiled from some language to ASM, which is machine the code. It is directly executable. For starters, a modern CPU has at least two modes, in which it's running the core of the operating system itself, that what we call kernel mode, and a mode in which it's running program, which is we call it as user mode. When in user mode, the CPU can do a whole lot of things. That's what the second point is, which is a modern CPU has at least two modes. The third one is a program can draw to the screen freely, but needs to go through the OS and kernel mode to draw on its bytes. For instance, a mouse click is typically noticed in the kernel, not user mode. However, the OS or operating system dispatch the event to user mode and from here to the correct program. The other way around also requires cooperation, which a program can draw the screen freely, but needs to go to the OS and kernel mode to draw on its parts. Fourth, when the kernel mode needs to start a new process, it first allocates memory for bookkeeping and then proceeds to load the program. Similarly, the act of starting a program is typically a cooperation. The shell part of the OS is a user mode program too. It gets your mouse click and determines that it is a mouse click intent to start a process. Then the shell then tells the kernel mode part of the OS to start a new process for that program. So next, different operating systems use different ways to hook up programs with the OS. And lastly, the ELF format for binaries is used for a number of operating systems, and Microsoft uses its PE format on all its current operating systems. Which different operating systems use different ways to hook up programs with the OS. As a result, the loading process differs, and the file format for binaries can differ too. It is not absolute. The ELF format for binary is used use its PE format on all its current operating system. In both cases, the format does describe the precise format of the binary, so the OS can decide whether the program can be hooked up to the OS. For instance, if it is a Win32 binary, it will be in a PE format. Therefore, Linux will load that Windows 2000 will, as will Windows 7. A Win64 binary, on the other hand, is in PE format too, but Windows 2000 will reject it. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Qasdina Azlin binti Azhar. I'm a matric number is 2117040. Today I would like to explain about the example of the simplest program execution, which is about the content of memory and registers in hexadecimal. In simpler math, we can conclude that 2 plus 3 is equivalent to 5. But how about we want to allow the system to execute it by using memory and address? Well, let's see how we can understand it from the diagram that I have prepared for you. The first thing that we need to look at is at the instructions, which are 1940, 5941, 2941, and all these instructions are loaded into the memory. Firstly, we have the instruction of 1940 on the address of 300, but then we need to bear in mind that the leftmost number in the instruction, which is 1 in this case, will be the opcode to load accumulator from the memory. Hence, accumulator register is loaded with the value of 3 on the address of 940 without the opcode, okay? And then secondly, we have the instruction of 5941 on the address of 301. And again, the leftmost number in the instruction, in this case 5, will be the opcode, and this time is to add accumulator from the memory. Without 5 in the instruction, 941 in this case will be the address of the value of 002. And lastly, we have the instruction of 2941 on the address of 302, which will store accumulator with the number 2 as the opcode and 941 as the address. Previously, 941 is address and the value of 002 is on the address of 941, right? And thus, after the execution of the complete program, the address of 941 will be updated with the value of 5. And hence, we have already the result of the complete program execution on how we can add 3 plus 2, which is equivalent to 5. This is the overall and the simplest summary you can look for. Well, I hope it does help to understand better about the complex diagram before. That's all from me. Thank you very much for listening. Assalamualaikum.
So today we are going to learn how does a computer execute program. So this is the example diagram of program execution. So given this all the opcodes, yeah, alright. So all the opcodes here we will bring to memory, and then from the memory we transfer into system. In program execution, codes is referred as memory codes, which contain the instructions that represent actual operations to be performed by the system. This is all the opcodes, and from the opcode, the front of each number will be load and install. First, the processor will fetch an instruction from the RAM. And then the CPU will write the data. When an instruction has been fetched, then the address in PC will increase. New instruction will be fetched next. The data will be added together and been stored in IC. So 005 is in IC, and then 2 plus 3 is equal to 5. So 30, the number for 302 is increment in PC. Another instruction will next be fetch the IR. Lastly, store the final result in memory. And these are the final results after the execution.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Arash bin Abdullah alias Shamsuddin, and my material number is 2118279, and I will present about the conclusion of this project. Nowadays, we can deny that program execution brings a lot of changes towards humans' life, but bear in mind that everything must have their own pros and cons. Same thing happened to this program execution. For its pros, it can ease humans' daily life where human can solve a specific problem easily using the computer program and time to solve a specific problem is reduced. Second one is humans can store data safely and securely. We know that our data that has been created is safe online and can be accessed physically. It also makes it easy for us, the user, to access it anywhere and anytime. The third one is multitasking. We also know that operating system is a technical power and it can do a lot of work at the same time, so we as the user can multitasking and help us to finish many tasks in a little of time. For its cons, first one is costly. We know that purchasing computer parts nowadays is a bit pricey, especially the high-end one as they are smoother for us to use. Second one is system failure. If the central operating system fails, it will affect the whole system and the computer will not work. Moreover, an operating system is the heart of a computer system, without which it cannot function. If the central system crashes, the whole communication will be halted, and there will be no further processing of data. The third one is virus threats. Threats to the operating system are higher as they are open to such virus attacks. Many users download malicious software packages on their system, which halts the functioning of operating system and slow it down. The fourth one is fragmentation. Fragmentation in the computer is a state when storage memory breaks into pieces. Internal fragmentation occurs when the method of process is larger than the memory size. External fragmentation occurs when the method or process eliminates. And the last one is highly complex, where the language used is not understood by all people, which is C or C++. Operating systems are highly complex and the language used to establish this operating system are not clear and well defined. Besides, if there is an issue with operating system, user cannot directly understand and it cannot be resolved quickly. And that's all from us. Thank you. Assalamualaikum warahmatullahi wabarakatuh.